Okay, welcome aboard. This is our presentation on electron beam evaporation.
How does this technique work? So it starts off with the deposition chamber is set to be evacuated to a pressure of 10 to negative 5 torrs. One must make sure to the material is being evaporated is in the compressed solid form or and then placed in the cubicle, which is the source. The electron beam is set to a high kinetic energy and its focus is set to the material. Kinetic energy is then transformed to thermal energy, allowing for evaporation and deposition. The E-beam then allows for the material to be heated to its melting point and evaporates the material due to electrons undergoing thermonic emission. And then the breaking vacuum, the E-beam evaporator can rotate different materials in the beam path, allowing for more material to be deposited. After that, the film thickness can be measured after the deposit occurs.
My name is Ihoma, and what the electron beam evaporation does to the surface of the material you're working on is that once you take the material and you put it into the machine, a high beam evaporates the material and it deposits the material onto a substrate. What is deposited is a thin filament that can later be used in the choosing of the engineer using it.
Hi, this is Steven, and I'm here to talk about why we might want the surface this way, as performed through electron beam evaporation. Sometimes you might be looking for a surface that's on the order of just micrometers thick. And the reason for that is that sometimes materials can serve great as bulk properties, and other times their surface properties are more valuable in different situations. So imagine we might want to create a bulk material with adjustable or adjusted surface properties. And we can do that with electron beam evaporation due to the fact that EBE technology enables surfaces to be made of materials with extremely high melting points. And to give it some perspective, when we talked about ceramics a few weeks back in terms of sintering, and we said really high levels of heat, that's on the order of 1200 degrees Celsius. But let's say you wanted to take a cobalt chromium piece and coat it with a stainless steel and then titanium layer, you'd be talking about melting points in upwards of nearly 1700 degrees.
Hello, my name is Maria, and today I'll be presenting how can this technique be used in biomedical engineering. Electron beam evaporation is used for optical thin films ranging from laser optics, eyeglasses, and electron beam evaporation is used to give the desired conductive, reflective, transmissive, and qualities.